In this lesson, we're going to be looking at proportional relationships. By the end of this lesson, you should be able to use proportions to solve problems and find the coordinate given the slope of a line. Proportional relationships, these are relationships that lead to symmetry. A couple of real-world examples of this would be the Egyptian pyramids. The Egyptian pyramids were built proportional. They used proportional relationships, mathematical relationships, to help keep these pyramids symmetrical. When we talk about the District of Columbia, Washington, D.C., Thomas Jefferson demanded that government buildings be perfectly symmetrical because it was a sign of government stability. So they used mathematical relationships to develop symmetry through proportions in these real-world contexts. When we talk about proportions, proportions relate to analogies. These are things where we look at this is to this, is that is to that. Proportions are the same thing. There's a specific outcome or a specific relationship between two things. So we can see that scissors are to cut as broom is to sweep, right? We can see that car is to mechanic as body is to doctor. We're looking at how are these things related. We can see mantle is to mantle as jam is to jam, black is to white as up is to down. When we're looking at comparing two things, we're looking at these similarities, these specific outcomes that come as a result. So when we look at a proportion is a statement where ratios are equal. And one way to check to see if ratios are equal is if their cross products are equal. If their cross products are equal, then their ratios are equal, and that means their ratios are proportional. When you're looking at a graph or looking at, specifically looking at a graph, your graph will go through the origin. It'll pass through 0, 0. This means extremes property of proportion. Means extremes. This sounds like a crazy word, but this is the property that actually allows us to check cross products. So what this says is it says the product of the means is equal to the product of the extremes. So in a proportional relationship, the means, okay, this is the middle part, so this would be this part right here of your proportion. If you multiply them, should be equal to the product of our extremes. We call it the middle or for the means because if we write our ratio as A to B instead of A over B is equal to C to D instead of C over D, the means, the B and the C part would be in the middle, and the extremes, the A and the D part would be at the end, would be on the outside part. But this just says that the cross products of the means, which is B and C, is equal to the cross product of the extremes, which is A and D. And so this is the property that allows us to check, to use the cross products to check for proportionality. Proportionality and proportional relationships come in handy because what it can allow us to do is it can allow us to find the missing coordinate if we're given the slope and the other coordinates in that point. Now typically we use the coordinates to find slope, but this idea of proportions allows us to work backwards. So what we would do is we would substitute all of the information that are given. So we would substitute in the 3 other coordinates and slope. We would simplify the fraction, and then we would cross multiply, and we would solve. And we'll see an example of it a little bit later on in this video. We want to use the cross products to determine whether each pair of ratios forms a proportion. Remember that this property is called the means extremes property. So it's saying that the product of the means should be equal to the product of the extremes. So if I check the product of my means, so this would be, or my extremes, so this would be 11 times 12, which is 132, should be equal to the product of my means, which would be 4 times 33, which would also be 132. If they're equal, then they're proportional. So these ratios are equal, so these ratios would be proportional. So these would be proportional. So yes. Yes, on proportional. If we look at B, again, we look at the product of our means to the product of our extremes. So our extremes would be 17 times 8. So 17 times 8, which would give me 136. If we look at the product of our means, which would be 9 times 16, which would be 144. 136 and 144 are not equal. So because these two things are not equal, this means that these ratios are not proportional. They're not equivalent. So no, this would not be proportional. We can solve for a missing piece when we're talking about solving for proportions. So again, we're going to cross multiply. Because remember, our product of means extremes allows me to use cross products. So I would multiply 4 times 6, those are my means. So 4 times 6, which is 24. My extremes, which is 3 times x. Remember that my means should equal my extremes, so 24 should equal 3x. And then if I solve this equation, we get x is equal to 8. So we know our missing coordinate is 8. You could check that. 8 times 3 is 24. 4 times 6 is 24. Those ratios should be equivalent. They should be equal. If we're looking at the next one, again, cross multiply, the means should be equal to the extremes. So my extremes, 15, 3 times x plus 8 should be equal to my means, which is 15 times x. And then we can solve the equation. So this would be 3x plus 24 equal to 15x. We follow our property of solving equations. So you get all your variables to one side. 24 equals 12x. X would have to be 2. And so we know that x in this case is 2. Again, we could check that. Okay. 2 times 15 is 30. 2 plus 8 is 10, and 10 times 3 is 30. So our means and our extremes are equal, so we know that x in this case is equal to 2. If we're looking at finding the x-coordinate of this point, we would use our slope formula. So remember slope formula, this is the y2 minus y1, x2 minus x1. So we're going to work backwards to find the missing coordinate. We're going to plug in all the information that we know, and then we'll solve. So if we know y, and if we label these points, if I label this x1, y1, and I label this x2, y2, it will help me a little bit, but my y2 in this case would be negative 1. My y1, or y1 in this case would be 2, so minus 2. We have x2, which is 5. What we're missing is the x1, so we'll leave that as x. And we know the slope is 3 over 4. So following that means extremes property, the first thing that I'm going to want to do is I'm going to want to simplify this top piece. So I want to simplify negative 1 minus 2. So that would simplify to negative 3. And then we'll check our cross products. So cross products here, this would be looking at 5 minus x times 3. Equaling the negative 3 times 4. Remember, cross products should be equal if they are proportional. So negative 3 times 4, that's 12. Negative 12. And then solve it. So 3 times 5, that's 15. Minus 3 times x, which is 3x, equals negative 12. Get your constants on the same side. So negative 3x is equal to negative 27. Divide both sides by negative 3. And we get that x is 9. Again, you could check that. So once you know what that value is, then substitute it back in. So we know that this is 9. 5 minus 9 is negative 4. So this would be the same thing as negative 3 over negative 4, which we know is the same thing as positive 3 over positive 4. Again, same thing, find the value of the y on the point given the slope. So we're going to work backwards. So the y2 minus y1, x2 minus x1. Again, I would label your points. So So in this case, we're missing y2, so we'll leave that as y, minus y1, which is 2, over x2, which is 9, minus x1, which is 6, is equal to our slope of -1. And because it's not already a fraction, I'm going to write it as a fraction by placing it over 1. Again, simplify the bottom. 9 minus 6, that is the same thing as 3. And so then we will check our cross products. So if I cross multiply 3 times -1, that's -3. I cross multiply y minus 2 times 1, that's going to be y minus 2. And then solve it, get your constants on the same side. You see that y is equal to -1. Okay, we can check that. So again, if I put -1 up at the top here, -1 minus 2, that's -3 over 3, which is the same thing as -1 over 1, or -1. If we're looking at real-world problems, again, you're setting up the proportion. Again, make sure that you're doing, that you're being consistent. So it says Billy is 6 feet tall, and he casts a shadow of 5 feet long. Because his height came first in the problem, when we set up the proportion, we're going to set it up as person to shadow. So his height to his shadow length. The flagpole casts a shadow of 15 feet long, and is how tall is the flagpole. So if we do person to shadow, he is 6 feet tall, and his shadow is 5 feet long. For the flagpole, we're trying to figure out how tall the flagpole is, so we don't know that part, but we do know the shadow is 15 feet long, so keeping that proportion in mind. If we cross multiply, 6 times 5, that's 9, or 6 times 15, that's 90, equals 5 times x, which is 5x, and then dividing by 5 on both sides, we'll get x is equal to 18. And it would be 18 feet, so don't forget to include our units here. When we look at Jason's going on a 20-mile bike ride every Saturday, he rides the distance in 4 hours, so 20 miles over hours. At this rate, how far can he ride in 6 hours? So again, we're missing the number of miles. We know the hours. So again, you could cross multiply and solve. This would be 120 if we multiply across here. That's 4 times x, or equals 4 times x. Divide both sides by 4, and x equals 30. So we know that in 4 hours, or in 6 hours, he could go 30 miles. Okay, looking at our last example here, we have Fred can drive 120 miles on 5 gallons of gas. So 120 miles over 5 gallons is the first ratio. How much gasoline can you do in 350 miles? So 350 miles, since we put it on the top in the first one, goes in the top here. And then we can solve our proportion. Now, what I would recommend here is simplifying this fraction first. Simplify before you start multiplying across. 120 over 5 can be simplified. 125 goes into 120 24 times. So we can simplify that to 24 over 1 equals 350 over x. That might be helpful for us because then I'm dealing with smaller numbers. So 350 would be here. If I multiply 1 times 350 equals 24x, and then all I'm having to do is divide 350 by 24 to give us 14.5. 83 repeating. So on about 14.5 gallons of gasoline is how long he'll be able to go 350 miles. All right, to find the missing coordinate of a point, we use a proportion. How? How do we use proportions to find the missing coordinate of a point? This is what I would like for you to consider before watching the next video. As usual, please subscribe so that you get updates on new videos as they come out.